Hello, this is David Taylor from Riverwood Healthcare Center at the On Call podcast. Thanks for joining us again. Today we are going to talk about light. We're going to talk about light as medicine. So light has come into the podcast world, the social media world a lot in the last few years, at least that people have asked me about and that I have seen with regards to circadian rhythm, about when to get light in your eyes and how to turn off your screens at night and when you should be turning them off and how dark your room should be when you sleep and all of that. But that's actually not what we're going to talk about today. We also aren't going to talk about UV and the importance of vitamin D for your system. We're going to talk about near infrared light and how that impacts your cellular health and your overall health and why this is extremely important. And probably is going to be more and more recognized as an important component of your health as we move forward. And by move forward, I mean move forward in the next few years to next few decades. So we think of light, of course. Most people know about UV, and we know about the visible spectrum, and we see a rainbow, and we think of Roy G. Biv because of the colors of the rainbow in the visible light spectrum. UV is short wavelength and it's invisible, and it's on the blue side of things because it's ultraviolet, so it's on that side of the spectrum. But there's also long wavelength invisible light, which is infrared, and there's near infrared and far infrared. Well, why is this important? Why do we need to know about infrared light? Well, we're going to start because it affects your cells and it affects the mitochondria in your cells. So let's talk about what mitochondria are. Mitochondria are a component of your cell that you can best think of as your cell and your body's engine. It is what produces energy in the form of something called ATP, but that's not really important. It's at least not important for our community and our topic today to know what ATP is and how exactly it's made. Just know that the mitochondria make energy, and that energy is used to drive your entire system. Well, you know this just from living a daily life after a long day, or if you're a person who works out a lot after a hard workout, or if you've been really stressed, you get run down. The same thing kind of happens with your mitochondria. They get run down when they're overworked or stressed. And when that happens, they produce something called oxidative stress. And this is where free oxygen radicals are made, and this is where we get into chemistry. That's also not important. Just know that oxidative stress, when there's too much of it, is a bad thing. Kind of like that old trope, everything in moderation. A little oxidative stress is actually important for you to be able to respond to infections or other stressful things in your life, but too much of it puts a burden on your system and actually causes harm. This oxidative stress is linked to inflammation, which is oftentimes linked to heart disease and cerebrovascular disease, which is a fancy way of saying strokes or risk for stroke. And then inflammation is also linked to cancer, diabetes, dementia. So how do we combat oxidative stress in our system? This isn't something where you can just say relax. This is at a cellular level. How do you relax, quote unquote? Well, melatonin. And we know about melatonin, or at least most people are pretty familiar with melatonin when it comes to the pineal gland. They may not know about the pineal gland, but they know what happens when you're sleeping, and some people take melatonin to help them sleep. Well, it's a very potent antioxidant. Melatonin is released by this gland, which is in the base of your brain, and circulates through your system to help restore your system, and this is part of why sleep is so restorative. For those of you that have been following the podcast, you may remember that Dr. Arnold and I did a podcast on sleep, and this is something I'd refer you back to because an overview of why sleep is so beneficial is important, but part of that is the release of melatonin and the fact that melatonin is such a potent antioxidant. This is why there's all this talk about sleeping in a dark room and how much good sleep is important. Well, what about during the day? How do you combat oxidative stress during the day? The pineal gland, from what we're talking about, is shut down if there's light outside that your eyes are taking in. And that's why we don't want light at night. So how does this work? Well, sunlight or light that you're exposed to, whether it's from the sun or not makes a difference in how you combat oxidative stress during the day. So before we go into that part, let's talk about light itself. 7% is UV, 39% is the visible spectrum, the Roy G. Biv that we talked about, and 54%, the majority, is infrared. That's the near infrared and the far infrared. And then just to get a few more terms out there, 1 lux is the amount of light a candle at 1 meter away from a surface would project onto a 1 meter square area. That's the amount of energy that candle light. So it's a very dim amount is what you probably need to know 1 lux is. And to give some context, sunset is 10 lux. An office that you might be sitting in, or even a well-lit room with artificial lighting, is 300 to 500 lux. An overcast day, even if it seems dim out, is 1,000 lux. And full daylight, depending on where you are and the intensity of the sun at the time, is anywhere from 10 to even greater than 50,000 lux. So the reason I'm bringing up the lux is just to give you an idea of the comparison between an overcast day, even in a nicely lit office room. You're getting much more light energy that can potentially affect your system on an overcast day outside than you are in an office space. So we know that non-infrared light from the sun actually goes straight into your cells. And the reason for this is its long wavelength. So unlike UV light, which is short wavelength and can be blocked by sunblock, by clothing, by a wall, by glass, non-infrared radiation can go through things. It can't go through every glass, and we'll talk about that in a little bit in terms of different types of modern glass versus older glass or glass in older buildings. But it can go through clothes, including jackets you might be wearing, a hat that you have on. And this is important because you can protect from too much UV light with either sunblock or with clothing, and yet still get the benefits of near infrared light. There was a 2019 study by a commercial light engineer and a University of Texas professor that helped show that the near infrared radiation can go straight into mitochondria, and that produces melatonin. And that's the way this works. Let's talk about that now. The pineal gland produces 5% of the melatonin that you have in a given 24-hour period. 95% are produced by mitochondria all day. So the melatonin produced at night is really just a reservoir for supporting your normal mitochondrial production of melatonin. And this is important because you need that to combat the oxidative stress, and you need it being made essentially all day so that you're ready to handle whatever stress might happen. You don't know when you're going to get infected. You don't know when certain things are going to happen. And to have that intracellular melatonin ready at any given time is important for your system. So it's really, I think, best to think of the nighttime melatonin production as a replenishment and a bolstering of your normal daytime cellular melatonin production. And it doesn't put you to sleep because it's in the cell. It's not circulating through your system. It's not part of the sleep cycle. Because when people think of melatonin, I think they often think, well, this is something I need to either help me sleep or it's going to put me to sleep or it's part of the circadian rhythm. This is a different way for us to think about it. So we get this into our cells through exposure to sunlight or incandescent bulbs or fires. Like I said before, it can go through sunblock, clothes, goes through your skin, it can go into your bone, and fascinatingly, it can get into your brain via your cerebrospinal fluid, and it gets to the cells in your brain and helps stimulate the melatonin production. And this is why it's proposed that it helps prevent dementia. So UV, the short wavelength doesn't penetrate well. You need actually to have your skin exposed to the sun to get the benefit of that. You do not need that with near infrared radiation. And I think that's the take-home point, and that's why I've said it a few different times. Direct sunlight is the best. And if we go back to when I talked about the lux, an overcast day is producing enough energy that you get 1,000 lux versus an office space, which is producing 300 to 500. Now, office spaces are problematic because modern office spaces don't have incandescent bulbs anymore. So LEDs or compact fluorescents do not have any near-infrared radiation that you're getting, which is part of the reason I think this is such an important topic for us to talk about and a change from how things used to be to how they are now. Another way that you get near-infrared radiation is by being outside in green spaces. So a countryscape or an urban park versus a bunch of skyscrapers or a bunch of urban buildings. The difference there is you are going to get more near-infrared radiation into your system in those green spaces or in an urban park than you are walking between office buildings in a city or a town. Especially if you're in the shade, you can still get radiation that's reflecting off of those green spaces. And if you ever see images of near-infrared radiation photography, you'll see that trees, leaves, grass show almost like white light, or they'll be very brightly colored, and a rock or a building will be dark. And that's because it's not reflecting much of that near-infrared radiation. So they've shown, actually, in an environmental research study in 2018, that people living in green spaces, which, again, I think of as the country, but can also mean, or rural areas would be a better way to say that, can also mean people who live in a city that makes sure that they're exposed to the classic one would be Central Park in New York City. They have decreased diastolic blood pressure, decreased resting heart rate, and decreased stress based on testing of salivary cortisol. This means there's a potential reduced risk for diabetes, cardiovascular disease, premature death, and a meta-analysis in 2018 showed that. The problem is there's many factors that go into diabetes and cardiovascular disease, so it's not just living in a green space that's going to do that, but it's one of the things that puts the odds in your favor. So let's talk a little bit more about what is actually happening in the cell to get a better understanding of this. In 2016, there's a study that took a very specific wavelength of near-infrared radiation and directed it at the skin with a laser. And they did this where, of all the people, half of them got the laser and half of them just thought they did because it was a placebo. And in this enzyme called cytochrome C oxidase was increased. And this is increased via nitrous oxide, which, again, the details of these intracellular processes don't matter. But it is important to know is all of that stimulated amazing amounts of melatonin production within the mitochondria and within the cell itself. They also showed that when this happens, people have decreased glucose metabolism, decreased lipid metabolism, and worsening problems with their diabetes and worsening problems with their lipids if they've had decreased light in the previous 7 days. So it's so potent that in as short as 7 days of decreased light exposure, you'll have decreases in metabolism of your blood sugar and of the lipids like the cholesterol that's in your system. This was shown in a really big study in 2018 where they compared groups of people in the United Kingdom and the Netherlands and were able to demonstrate this. It was 13,000 total people split equally between the United Kingdom and the Netherlands, and they studied them, I forget the time frame, but they studied them over time and were able to show that in those very short windows where light was decreased, and it was decreased over a few days' duration, that you already had effects. That's how potent this effect is. So is sunlight dangerous? Well, it can be. We know about UVA and UVB cause oxidative stress to skin cells, and even though they don't penetrate very deeply, they can get into your cells and cause skin cancer. There's some question as to whether melanoma is really caused by excessive sun exposure, though throughout my medical career, that was something that we had taught to people is excessive sun exposure is going to potentially put you at risk for melanoma. It certainly does seem clear that basal cell carcinoma and squamous cell carcinoma are at risk when you have increased UVA and UVB exposure. Melanoma, maybe there's some question about that, but still we know that too much UVA or UVB can be risky for you. Well, can you get too much near-infrared radiation? The answer seems to be no, because people can live outside their entire day, especially if you think of the way people used to live in the past versus how we live now. And they didn't seem to have any effects from that side of the light spectrum, not the visible light spectrum, but the invisible light spectrum. So I think it's important for us to talk about how this melatonin production also protects us, not just from things like glucose metabolism and decreased inflammation, but how does this protect us in infectious diseases? So several studies have shown with influenza and with COVID that sunlight helps bolster our immune system. And again, the thought is because of that internal melatonin increase in production. So COVID-19, because that's been such a big topic in recent times, let's talk about that. COVID-19 blocks the ACE2 receptor in cells. And some of you may remember that that was thought to be the reason that people could get so sick. It, again, doesn't matter if you remember the specific enzymes or the pathways. It's just important to know that the ACE2 enzyme helps convert something called angiotensin 2 to angiotensin 1,7. That's not the important thing. It converts one of those from being a pro-oxidant to an antioxidant. And COVID blocked that. So then there was a pro-oxidant that was causing oxidative stress, that was leading to inflammation, was leading to people getting really sick. When people were exposed to near-infrared radiation, if you are increasing the melatonin, you're battling the inflammation, you're battling the oxidative stress that COVID was leading to. And they actually found that this worked as a treatment for COVID. So there was a small study where people were placed with a light vest, and that light vest was either turned on or not turned on in COVID patients. And my understanding is they may have stopped it early because of the effects that they were noticing. So this light vest would kick out red light, near-infrared radiation. And they only needed 15 minutes a day. And the patients didn't know whether the light was turned on or not. And the doctors didn't know whether the light was turned on or not. So it was a blinded study. And they found that oxygen saturations of these hospitalized patients improved with the light versus without the light. They also found that people were discharged 4 days earlier from the hospital if they had the light than if they did not have the light. Now, this was a small study. It was only 30 patients, so it's not a super powerful study, but it helps support this idea that light can help you fight infections and help bolster your immune system. There was a 2021 study in the British Journal of Dermatology, not where you would expect to have a study about COVID, but it showed that deaths from COVID in 3 different countries during the Delta wave, which was fall of 2021, winter of 2021, the deaths decreased when sun exposure increased. And initially, some of you may remember that there was a thought that vitamin D was the reason behind this, and that if we did vitamin D supplementation, people were going to live longer. And areas where people had low vitamin D had some increased COVID infections and increased COVID deaths. Well, turns out that vitamin D supplementation didn't work as clearly as we'd hoped. There were some studies that had maybe some benefits and others that showed none. And it didn't become a standard treatment. But then we see that there are other things that suggest it wasn't actually the vitamin D side of things, but it was probably the near-infrared radiation and that effect that we talked about in the mitochondria and increasing melatonin that may have actually been the benefit. We've actually found this over years with TB patients. TB patients historically in the early 1900s were taken outside for periods of time every day. Pneumonia patients during the Spanish flu epidemic, people were taken outside when they were hospitalized. In war, they've shown studies that people who were recovering and rehabbing from war injuries did better if they were outside during part of the day versus kept in a hospital or kept in tents for their entire recovery time. Orthopedic injuries have done well, and there's multiple observations that have been made in the medical historical literature and then also in studies that suggest that there's benefit to just being outside, getting fresh air, and part of that benefit is most likely this near-infrared radiation. So I think I've tried to drive home the point that this increased melatonin production is really beneficial. So what's hindering us now? Why is this important now? We live longer overall than we used to. We have more chronic diseases, but we have medicines that help combat that. Why do we need to focus on this? Well, one of the reasons is it may help combat some of these chronic diseases, either they're before they develop or once they have developed. Two, we aren't getting near infrared radiation like we used to. We used to be around fires. We used to be out in the sun, living outside. And now we spend more and more of our time inside. And when we are inside, we're behind glass that blocks infrared light. We have low E glass now, which is good for energy, not losing heat through your windows, but it's bad for letting in infrared radiation. And the amount of time that we spend inside is, I believe, over 90% for most Americans now. I believe 7% of the time is spent outdoors based on national statistics. Obviously, that varies based on what you do and your individual circumstances. But getting outside is probably much more important for your health than you think, and can have unseen effects that are building up over time by keeping you from either developing some of these chronic diseases or fighting off infections where you might not have otherwise if you were actually getting that outside time. And based on that one study, only 15 minutes is really needed. Now, that was focused light right on a patient's chest when they had COVID that was causing them to be hospitalized. So that's somewhat of a unique situation, but a rough recommendation of getting out for 15 minutes in the summer where you're not wearing as many clothes, or 20 to 30 minutes during spring, fall, winter where you might have more clothes on and you need a little more time for the energy to penetrate through. A little bit longer on an overcast day versus on a sunny day. But these are things that you should probably try to do every single day to get near infrared radiation into your system and to help bolster that intracellular melatonin production, which has benefits across the board for you and may help. It may be the tipping point that, again, keeps you from being hospitalized with an infection, especially as you get older. It may help stave off diabetes, those kind of things, at least as part of a total healthy lifestyle. So that's the main take-home point that I want to talk about with light as medicine. This is not the part that people usually think about with light, but it's something you can do for free and might have a lot more benefits than a lot of other things we do. And time will help tell that as we keep studying it. So as always, thank you for joining us. I know this one got into the weeds a little bit, and I tried to stay out of the details of cellular energy production and enzymes and all that, but I can go into more detail if that's questions that people have as well. All right, thank you very much.